Okay. So this one is a GitHub link, okay, for the PySpark examples. Okay, so these are all the transformations examples are there. Okay. Okay. So first of all, like if I want to use some GitHub link, this one, how to configure in PyCharm. Okay. So once you have installed PyCharm, you can import the project. You can statement. Okay. So file, new project, or we have to take it the project from the Git VCS. Get from the version control. Okay. If you place your this GitHub link, if your GitHub is not installed, install the GitHub. Okay. The option will come here, and we have to clone the project. So entire project we have to clone. So once the project is cloned in your PyCharm, like you will see like this, your project is cloned. Okay. So there is a resources folder is there, and we have all the examples are here. Okay. So here it is taking the Python interceptor. Okay. It is indexing. So first you import the project, because without importing project, you cannot see all the examples in the editor. And here you can easily navigate the source code. Okay, because there are the all the examples of the different examples are there. You can see here. Okay. So first thing is coming like how to create a session, right? How to create a Spark session. So if we are using the PySpark shell, right? So we can get the session directly. But if I'm using in the PyCharm editor, so PyCharm editor, I have to create my own session. I have to create the session by using the Spark session class. I have to create the new session. Okay. So generally in the terminal, right, when you are using the PySpark, you will get the session. But here you have to create the session for each and every example. So you have to create a session first, because session is a wrapper of your program, because it is providing a Spark context, Hive context, SQL context. So it's a wrapper on top of the different context is providing a session. So you can have multiple sessions also, right? You can create multiple sessions for your application, okay, to connect your cluster, and you can execute your program, okay. And Spark session is wrapper. Basically, it's on top of the Spark context. So all this context you can use within the Spark session. And Spark session came into 2.x version. Now the 3.x version is there. So 2.x version, the Spark session is introduced. But before that, only Spark context, SQL context, Hive context, it was there. Okay. So whenever we are reading any file or we are writing any file, so we have to use the session. So session is the entry point. So we use the session. Okay. So once we are starting the program, by the Spark session. And once we have the Spark session, then we can read the file or we can do any transformation. So once the session is there, we can get the data frame or RDD or data set. Okay. So depending on the use case, right, from where you are reading the data, you can get the either RDD or data frame. So I already discussed about that, because RDD we are getting in case of we are reading a text file. And if you are reading any schema based file, right, any SQL databases we are reading, or we are reading from the JSON, CSV, XML, Parquet, Avro, ORC. So all these are giving the data frame. Okay. So we have the methods are there, right? Spark.read.csv, Spark.read.parquet, Spark.read.avro. So all these are methods are there to read the different file format data. Okay. And if you want to take it header from your data, so you can use header true. And one more property is there, infer schema. Okay. So one more property is there is infer schema. So infer schema is true. So when you are writing the infer schema true, so infer schema is basically uh, like you want to take the column data types of your data. Okay. So infer schema true. Infer schema true. Okay. Or another way is you can create your own schema. So when you're creating your own schema, you can create a schema struct type. So struct type, and there you can define the struct field. Okay. So struct type, and within struct type, you can define the different fields you can define. Suppose my one field is a ID, and ID is a integer type. Okay. Integer type, and like this, you are defining different structure. Even you can define in a struct field, like suppose you have a array type of field is there. Okay, one field is the array type, one field is a object type. So you can define the array of struct type. You can define array of again you can define the array you can define, okay, in the schema, and that schema you will be providing to your RDD. Okay, you can attach with the RDD, or when you are reading a data frame also you can attach. Okay, so then you will get the data frame, okay, with the schema. Okay, so let's see some example here. Okay. Okay, how to add a new column? If you have a data frame, so first of all, we are creating a Spark session. So this is a Spark session. We have from my PySpark.SQL Spark session. Okay, and it's one more thing is, like, suppose if I want to, like, I will get a compilation error because I just imported the project. So you will see here the compilation errors are coming because it's saying it's not able to resolve Spark session. It is not able to resolve. So what it needs to we have to provide the libraries. Okay, so how to provide the library? You go to the project structure and settings, and there we have to add the Python library. Okay, so we go to the settings, because if you are not able to fix the compilation error, so you can't proceed, right? You can't run your code. Okay, so we have to run the code. So we go to project structure, and here we have to add the content root. So when you click on this, you have to provide the Spark installation, right? There we have libraries. Okay, so I have to go to my software folder. There the Spark. I have to go to the Spark, and there is Python and lib, and I have to select these two chip. Apply. Okay, so this thing you have to, this setting you have to do in your PyCharm for your project. So once this library will be added, your issues will be resolved.
So we are adding here Python library. What about Spark library?
Both we needed. Okay. So by default, Python is there, but Spark library is needed. We need to add the Spark because there's all the data frame, all this RDDs, everything, right, related to. So there is
But you
Python.
have added Python library right now. We need to add a Spark library.
There are two libraries, right? Hmm. Yeah. One is a PySpark.zip is there, and one is a
Okay.
Py4j is there. Okay.
Huh.
Hmm. So
And where this code will run means where we need to make a jar file or it will run here
no, here we are running directly
automatically.
in a py file, right? This is the no need to create a jar, right? Jar is we have to create in the Spark, Scala or Java project, okay? But in the Python project, we have the py file, that is the main class, okay, main file, and we can directly run the main file, okay?
In
But
real
here,
time,
without main also we are able to run because it's a directly Python script, right? Python script can run directly, right? Mm. We are executing the code, right?
okay. And in real time in companies, we
We
will have
write a
this
main function, and there we have, because there could be a chance multiple files are there, right? So how to identify which main file you want to trigger, right? So we specify our one, right? Okay, there are so many main file are there in your real-time project, okay? So you will be giving that main file, you will give whatever Spark submit you want to do, okay? So we will be using that file. Okay. And that file is calling different packages, and that is different thing, right? Okay, your that file is calling different modules, right? Different module libraries you are calling, right? Because everything you cannot write in a one single file, right? So you are calling from the different libraries or different other files, you are writing your code, right? Hmm.
So means we go to the Spark and we will write a Spark submit, and after that main file name. So from where it is going to pick that, it will come to know that okay, here is the main file. Because I'm not getting the clear
Yes,
picture.
yes, yes, yes. Okay, main file, see, it's like whenever you are executing the any code, right? See, this code is without main file, we are able to execute, right? Okay. So even, but in the Spark, right, when we are running on the Spark submit, right, when we are doing on the terminal, right, on the cluster, then we need it. Here we are getting all the environment is there, right? In this editor, right, we are providing the environment, right? Okay. But when we are doing that in the cluster, then we have to, generally we write a main class only. Okay, main class we write. Okay, because maybe other files, there are no main class because we don't need to run those one. Okay. So whatever file we want to run, we will keep it main class. Okay. So here now this code is running. So how the output is coming? If we see, this is coming as a data frame. So here is a hard-coded data frame I create data, right? This is, you can see, this is a tuple, right? List of tuple. This is a list of tuple. I have a first name, last name, gender, and I have a salary. So like this, I have a 4 columns. So I have created my 4 columns list, okay? And I'm giving my data with schema. Okay, so here I have not created a struct type schema. Actually, I can create a schema, that type of schema also I can create. When I want to specify, okay, my first column is a string, second is a string, salary is a integer column, right? Or double, right? So I can go for a struct type schema. So here I'm not doing any calculations. So I'm just taking all the field as a string type. So I have just defined the column names and I have just attached the data with the schema. Okay. And now I'm going to do data frame dot show. I'm able to see my data. Okay. Now the second one is I'm just checking the salary one not in the df one. So salary one column is not there. Like suppose I want to do some conditional, um, like how many columns I have. I want to check any specific column is present or not present. So not in. So these all things we learn in Python programming, right? We know membership operator, right? In or not in. Suppose something you want to check in, right? So you can check. So this is just a conditional things, whether I have something in my column or not. So I want to print that. Okay. So So salary one is not there in the columns list, right? That's the reason it's printing AA. Okay. So this is like some conditional statement you are doing on your list of. This is simple. This is nothing related to Spark. Okay. This part. This is okay. This is just simple. I'm just verifying my columns. So sometimes I want to check my column names and column data type. So I can write a conditional statement and I can verify. Okay. And next is I want to add a one new column, bonus percentage. So when I'm adding a with column bonus percent, so every rows I'm giving a same value. So there is a lit is there. Lit is a constant. Okay. So you can define the constant by using the lit. Okay. So you can add a new column. And the next is I want to calculate some bonus amount. So bonus amount is basically the calculation is whatever your salary multiply 0.3. So you are getting the multiply of salary, you are getting the bonus amount. So this is same thing you are doing with the with column, but you are doing the expression. Here you are doing, here you are doing the constant value. Here you are doing some expression. Okay. And suppose you want to do concatenation of the first name, last name, and I want to create a one name column. So concat underscore ws, these are the libraries functions. Okay. In the function, there is a library function concat underscore ws. So it will do the concatenation of your columns. Like you can specify and it will do the, so here you will see first name, last name, concatenation here. So first name, last name concatenation is doing. Okay. So if you have Next thing is you have the suppose current date you want to add. Current date means the date, current date, today date. So current date you are adding as a with column. So these are a very simple example of with column. Like you want to add column, a new column based on the your criteria conditions. You can add a new column. Suppose I say I want to create a one grade column depending on the salaries, right? If the person has the less than 4,000, greater than 4,000, less than 5,000, or if nothing is matching, otherwise C. Okay, so A, B, C, I'm giving a grade. Okay, so I'm creating a one new column. Okay, so this you understood, like how to add a new column. It could be a very simple like constant value, or it could be some calculation value like expression, or it could be something like a conditional when condition. So you can define the when and otherwise. Okay, so when condition you are checking the condition on your column. So data frame dot column name you are checking it. Okay, why do we have comma? Actually, we want to do concat with the comma, right? If you see here, actually, okay, you are saying like why the comma? Comma is coming here, right? In the first name, last name. If you want to do space, like we can put it a space, right? Like sometimes we don't want to put comma. So whatever way you want to do concatenation, so you are doing concatenation of the field. Okay. Okay, so this is clear, this all. This is just a with column. Okay. Now next is um, like aggregate functions. Okay, like I want to do the sum, average, mean, max. Okay, those kind of aggregate functions I want to use. So I have a same, like I have created data frame. I have a first name, last name, salary and department. Okay, it's going very slow. Okay, let us continue program here. Okay, so aggregate functions are basically we have the data first name and department, name, department, and salary. Okay, and once I get a data frame, so I can print a schema is printing the schema, like what are the types of data is there. So it is showing the schema. I want to find the distinct salaries, right? Approximate count distinct salaries. So I want to get I'm getting a collecting the top one. Okay. So I'm getting the all the salaries, then dot collect and 0 of 0, I will be getting the top one. Okay, the one salary. Same like I'm doing for the average. So select I'm doing on the average of the salary. So it will find the average of salaries and then it will take the one value. Okay. It is just retrieving the value. You want to just print it. Okay. Or you can, if you don't do collect, you can do the show function. You don't need to do print statement. So then you can do the directly, you can do the show function. So it will be showing in the it will be showing in the as a data frame. Okay, so then it will be showing as a data frame. And if you have to get the entire salary as a list, right? So you can use collect list. So collect list will be giving all the salaries, even the duplicate salaries are there. You can get the collect list. Same like you want to collect set. So collect set. So these are the functions all there here. If you see spark.sql, PySpark SQL function, and then you have a different functions are there. Collect list, collect set, sum, average, okay, mean, median, mode, right, okay, and variance. All these are the statics functions. All these are in the functions category. These are all the functions are there. So I'm able to use a collect list, collect set. So collect set is like if I have a salary duplicate, right? So I will get the unique salaries. So I will get the collect set. Okay, so I will get the unique salaries. Count distinct. So I want to get the count distinct, right? Like unique count I want to find, okay, in the department and salary. So two columns I'm giving. So based on the department and salary, it will find the distinct, okay. So distinct count it will find, okay. So these are the functions like we can have the last value, first value of the salary, max value of the salary. So this is some statics function there. Go to assess minimum value, mean value, skewness value, standard deviation, sum of the salaries, right? Total sum, and the sum distinct. So unique salary sum we want to get, like unique salaries count is there, distinct count, and same is the sum distinct is there. So these are the all functions are there. We can use the aggregate functions. So these are all aggregate functions. Okay, it's getting very slow. So these are examples of the aggregate functions. So when you run the code, you will see the result as these all are aggregate functions. Okay. If you come to the, like suppose your data is an array type data is there. So here you see this is a list of tuple, but there is a one field is a array. This is a one field is a array. Okay. So one field is this is a one field is a string and one field is a string, but this language at school is a array type. So if you see three columns are there, the one column is a string type, third is a string type, but second column is a array type. So when I'm having this one, what I want to, this is the array type, I want to make it as a concatenation. So I'm just using like concat ws and I'm giving this array field here. Okay, so it is doing the concatenation. Okay, so I want to print the name and the current state, and I want to print as a string rather than array square bracket. I want to print the data as a, if I print now df.show here, how it will print? It will print as it is square bracket. Okay, but when I use some function, so either you can use the Spark SQL query language or you can use dataframe API. So this is a dataframe API. This is a dataframe API, and this is the Spark SQL. Okay, this is the Spark SQL. So either one you can use. Either you can use the dataframe API or Spark SQL. If you are writing in the Spark SQL, same concat ws comma and column name you are giving. Okay, so here you are using dataframe API column. Column is a function, right? So you are using that. You are telling about this is the column. Okay, and this is the table. So some table you created here, some alias, some table you created for the data frame. So data frame dot create or replace them view. And after that, you are able to run the Spark SQL. So two ways you can do, either data frame API you can do, or you can do through, okay, I just do on this PySpark shell. It is slow. So you are able to see here, it is showing the print schema. It's saying here, this is a name is a string column. Language at school is a array type column. And within the array, you have field is a string type fields are there. Okay. Then we are showing the data frame dot show. So it will be showing as a data frame, as a tabular representation of the data. So you are getting language at a school is the array type. Okay. And after that, we have done the concatenation. Okay. So we are doing all the field of the array concatenation we are doing. So we are getting as a string. Now we are getting as a string. Now we are getting as a string because concat underscore ws is returning a string, and it is appending the comma after each field value of the array. Okay. So now I'm getting the value as a comma separated. Okay. So next is this is I'm creating a table for my array, the data frame. And once my table is created, then I'm just going to show as a same string. So result is same. If you look at the result is same. This is the difference, right? I'm doing here. The one I'm doing is here. This is a data frame API I'm doing, and here is I'm doing Spark SQL. Okay. So this code is basically showing data frame and Spark SQL. The same example, the data set is same. Now we are attaching with the schema. So this time I'm creating a one struct type schema. So for string type of field, I'm taking a struct field name. Another one is a language at school, string type. Okay. Another one more column is there. That is again an array. This is again an array. Okay. And this array is the language at work. And the fourth one is a current state and previous state. So I have a two states are there. Okay, current and previous. Okay. So this data, so I will create a data frame first. Okay, so I'm creating with the schema. Now I will be showing the data using the data frame and the schema. So whatever schema you defined here, the same schema will show. So now you can see here the data frame dot show you are doing. So simply name is there because we have done the concatenation. Language at school, language at work, current state, previous state. Okay. So I'm getting this all. Now I want to do the explode function on the array. Okay. This time I'm doing explode. So I want to make it separate of my this all three values, right? In my array, I want to make it separate. I want to make it as a separate row. So that is the reason I'm going to do explode. So if I do the explode, if you see in the column, because I have not given any name to this column, but I can give the name to this column. I can say dot as, and in the bracket double quote I can give language. Yes. Explode we are doing something alias. Dot alias. Okay, so this like you can get the data frame, you will get the languages is a separate. So you have done the explode. So for James with the 3 times is coming. You remember right in the high we have the explode function. Same explode function is here. This is the same explode. So this explode function is separating your arrays values into the multiple rows, right? You are You are exploding your array. Next is, suppose I want to use the anything I want to split it. Like my name is comma is there. In my name is comma is there. In my string values, comma there. So you can convert from array to string or string to array. So how to convert array to string? Array to string, we have done the concatenation. Okay. So we can do the concatenation. But suppose if I have the values is a comma separated and I want to make it array. So how to make it? I can use the split function and that will change to my column values into array because I'm doing the split. So you can see name as array is coming as a my array type is coming from the string to array. Okay. So this way I can apply the split function. Suppose I want to make it array of two columns. So two columns I have, I want to combine it. I want to combine it. So I say I want to make it one column. Instead of giving a previous state or current state, I want to make it one state column. Like how many state I have, I was there. Okay, so I'm getting the state. So you can create an array function is there, array, and then you can give the current state and previous state. Okay, so like this you can joining the columns as a array. Okay, so that you can do. One more is array contains. Array contains is you want to verify whether this particular value is contains in your array or not. So that will tell you. So it is telling, okay, the Java is present in this, Java is present in this, but Java is not present in this. So you want to write some condition when case and when condition, when condition you can write it here. If Java is present, okay, you want to, you can display some string. Okay, you can display some string. You can display some string. Okay. This is clear, everyone. How to handle the arrays type, right? So how many things we have seen here? How to apply the explode, first of all, how to make it array if the values are comma separated in a string, how to combine two values to make it one single array. Okay, and other one is if you have like check the whether it's present or not present, the contains is there. So just remember these things: array contains, array, split, explode. Okay, so these are the different functions. So you are learning the functions, right? Explode, how to use split, how to use array, and how to use array contains. Okay. Okay, the next thing is okay, broadcast I will tell later. Okay, so here is another one is a cast function. So sometimes I want to change one column data type to another type I want to change. Okay, so I have this data. Okay, so you can see here you have the data is with the these many fields are there, first name, last name, and these are the this is the schema is showing, print schema is showing. Okay, now you have to do some calculations things and you want to change the cast function you are going to use. You are saying here, I want to make it my age is the string type. My is graduated field, I want to cast into Boolean type. So it is coming true, true, false, like this is coming. Okay. Now you are making it previously, the age was integer type. Here, if you say age is the long type, and now age is the string type, and job is start and the is graduated date is a Boolean, is graduated is a Boolean now. Okay. So you have the previously string type. And the next one is a job start date. That also you are casting is a date type. So this one you are casting as a from string to date. So if you see job start date is a string type and here it is cast to date type. Okay, so this is just changing the data type. So how to change the data type from one data type to another data type? So you can change it. Okay. Another way, like you can use the some select expression you can do this way. Okay, so these are the other different ways are there. Like using the SQL queries, you think it is easy. You can do the Boolean function. You have a date function and you have a string function. Just pass the column. So you can do the typecasting. Okay. So the advantage of the typecasting is, suppose something you want to apply on the date. Okay, and you want to apply some transformations on the date, right? And if you don't have the date data type, right? So you have to convert to string to date. So if you make it your column data type is a date type, you can do the you can do the you can do the transformation easily on the date type. Okay. So that is the reason sometimes, so age is mostly we use the integer, right? Okay. But generally, if I'm just going to display the age, I'm not doing any calculation on the age. So I can make it string type. Okay. Okay. But date, generally we use like some date functions. I want to compare the date. Like suppose I want to calculate this is the like how many years this guy is working. Okay, so job start date and current date, I can do minus. Okay, so those kind of calculations we can do on the date. Okay. Okay, so this is the same like data type. Okay, so column functions. Okay, so these are the transformations, right? Okay, like filter function is there. So if I want to check the IDs between 100 and 300, whether the first name contains cruise. Okay, first name start with, end with, if the values are is null or not null. Okay, and like suppose the starting of the first name is anything, but ending with the om. Okay, so these are the transformations are there. Okay, let's do. So if we look at here, so this is my data. So I'm creating a full name, so I'm creating an expression, so I'm concatenation I'm doing. Okay, so I'm doing the concatenation and I'm creating a full name. I'm doing the sort function. The sort function I'm using on the first name descending order. So first name descending order, here is the T is coming on the top. Okay. So this is a sort function. If I want to do cast, so I'm doing the casting. So the column dot cast I'm using. I want to check the IDs. Like this is a filter. Filter is like I'm going to check on the column between, right, 100 to 300 values. So I'm doing this way. If I want to match exact value, contains, so contains is like if anything is contains cruise, right, though that row will come. So it will filter out the rows. Start with T, so T rows is coming. Is end with cruise, so this row is coming. If I want to find the null values, okay, so is null means wherever null is there, it will be showing those null. Okay, and you can drop NA. So there is a one function drop NA, right? Wherever null is there, you can drop NA function you can call. Okay, that I will show. Okay, you can fill the null values with something else. Suppose you want to do transformation and say instead of null value, you want to put it empty, blank value rather than null value. Okay, so you can fill NA is there. So two functions are there, drop NA and fill NA. Okay. So drop any and fill any, you can do. Okay, so filter is, this is the is not null, wherever is not null is there. So that we are doing. Okay. And this is R like or like, right? So this is basically we are doing the like operator. Substr. So we are doing substr. Substr, like I want to find substring, like some part of the string I want to find. So 1 to 2 character I want to take it from each rows. Okay. And this is again when condition. Okay. So when condition you are applying here. If it is gender is male, you are writing male. If it is female, like this, you are doing. Okay. So this is the way to display the data. And if you want to check some value is present in your list or not, suppose you have list is 100 to 100 and you have the column is DFID. So you want to check any value is 100 to 100 is there, any value. So those list you want to filter out. So is in is there. Is in basically checking in your list of values. If any values is matching, it is showing. Okay. And this is another data frame they are creating with the schema. So here is different types of like string fields are there, integer field are there, and some are the object type is there. Can you see the difference here? Which one is the object type? So here is again we are creating a one struct type. We are creating a struct type for what? We are creating a first name, last name. First name, last name is a, this is a object type. Okay. So struct type field I'm creating. This is a tuple type, object type. This is the array type, and this is a map type. So all these are the three different data types are there. Okay. Complex data types are there. So this is the object type. So again, I'm defining the struct type. And another one is the array type. So struct field is the array type. And struct field is the map type. So directly I'm saying the map type. So map type field name is a properties, which is having key and value. Okay. And languages is a array type. So number of values are there. And the first one is a struct type. So object type is there. It's an object type. So struct type and struct field. Okay. So when I'm going to see the schema, I will see the schema like this. I will see the schema like this. Okay. I will see the schema like this. I have a name, struct type, array type, and map type. Okay. And then if I want to get item of my language, so I'm using an index. I'm using an index here. Like I say 0, 1, 2. So based on the index, I will get the value from the array. If I want to get a key, so here is the key. I'm getting the value is a black. So if you see here in your data, so here is black is here. Here is a brown. Here is a red. Here is a black. Okay. So for all these four record, different value is there for the, here is the key. Here is a key. Okay. And if I want to get the, again, same thing, but here I'm giving a get field. So get field also giving the same thing. Okay. So either you can use get item or get field. And like first name value I want to get. So first name, I'm giving a first name. So first name data is coming. Only first name data is coming. Okay. So I'm getting the from name. Okay. So drop field, suppose you say you have a extra column and you want to drop it. So drop field is there. You can pass the list of column. So list of column you pass, then you will drop your column. Okay. So this is the with column, right? With column, you can add any new column you can add. Okay. So let all those things are there. Okay. Okay. So this is clear. This is all the other transformations types. So these are the all different transformation of the map, struct, and array. Okay. So how to use a map, struct, and array. So column operations. So like we have created data frame here. So this is all the hard coded data, right? They prepared the data and they are applying the functions, right? They are applying the functions, right? Start with, okay. If you want to replace something in your, so you can replace it also, right? If you see this one, this one. If you see here, what is the difference here? So initially you have a data with this two rows data, James and Annan. And this data is having one column is a string and one is a gender is a long value. Okay. Now simply I want to print the name, first name. I want to the first column, only one column. So select is there. So select is taking. So select, there are the different ways to you can take it select. Either simple column you can take or data frame dot you can give the in square bracket. So there are the different ways you can take it. With column, you are adding a new column. With the sub str, you are applying on your column, you are applying the sub str. So you are getting the two character. If you are going to start with J, so it's a filter, right? So filter you are applying, and you want to replace something. Suppose dot you want to replace with underscore for columns in df column. So you are saying here new columns you are creating, you are doing the column transformation. So existing column, like you are using here all the columns list. For each column you are checking where the dot is there, you are replaced with the underscore. So here names dot first name will change names dot names underscore name underscore first name. Okay, so this is kind of transformation you can do dynamically. It is, you are not doing hard coded, this is a dynamic you are doing, right? Wherever dot is coming, change to underscore. Or you can say any particular column having starting letter J, you want to change with something, right? You can do. Okay. Okay. Other way, what is there? Like for the column rename. So there is a column rename is there. So you can data frame dot column rename. So df2 dot.
Column.
So you have to give the existing column name, but here you can also make it dynamic. In the for loop you can do. Suppose you want to do multiple column rename, you want to do, so you can make it dynamic, but here I'm just showing already name underscore first name is change. Hmm.
With column rename.
Yeah, actually we have to add into the and you can drop the existing column. So drop, and my column is name. Still why it is not taking?
It's because with
With
rename.
column rename, right? With uh I think with column rename,
df2 dot with column.
something column renamed. Yeah, I written same, right? With column renamed, with column column. Data frame also having not data frame dot with column renamed. Data frame dot, yeah, it's there, right? This is old column. So if you want to, Which one is saying call should be column? df2 dot show. Okay, so column name is changed, right? Okay, so select columns. We can have a, we can any specific map, right? Map. This is the map data. So we can properties a map, right? So we can select the key value pair, like we can define. Okay. So this is all the operations on the column. Okay. So when we have the key value pair type of data is there. Okay. And we can convert map to, okay, like suppose I have a, this is the one, is the first name is there and map is there. And I want to change this to the, I want to get the specific properties of the, like the property. So here I'm using a lambda, right? So lambda is basically here, individual value of each row I'm going to take, like x dot name, x dot properties of here, x dot property of I. So I'm passing the key and getting the value, and I'm making it a one data frame. So if you look at here without this lambda, how it looks like. So if we see initially my data frame is coming like this. When I'm just defining this data frame and I'm getting the data frame is like map form, it is coming. Okay. So I want to change it to as a columns. Okay. Name column and I, this values column, and black, this is a here column. So three columns I want to define. So this is the way like you can use the lambda, you can iterate the data and you can define the data frame. Okay. So this way we can do conversion. Okay. Other way is also there, with column you can do. So df, you have whatever your df is there, add a new column, because name is fine, because name is fine because it's a string column. But this is a map value. So you take it, df dot properties get item, df dot properties get item I, and then you rename the, you can give the column names also, you can give it. Okay, so you have given the column names here and I. Okay, and we have dropped the properties. So property column we have dropped it. Okay, so we have dropped it. So this is same result is coming, whatever is coming here, it's the same result. Okay, or you want to use like this one square bracket, like we can get item or we can use the square bracket, we can give the key. Okay, and this particular code is I want to convert data frame to RDD. Okay, so I have all the keys data frame. If I look at here, so here I'm just using the map keys. Okay, so keys df, first I'm getting the, this explode I'm applying on the df properties. Df property is a map type. All the keys I'm taking by using the map key. So map key, what it will take? It will take all the keys name. Okay, map keys will be I, and here is the two keys are there. So I will take the keys and distinct. So I will get a data frame of this if I print this key df dot show. Key df dot show, because this is a data frame. See I and here, these two are the keys. Okay, and distinct key. After that, I did data frame dot rdd dot map, and I'm going to collect the key list. Okay, so I got the key list. If I see this key list is the, this print I do. So I'm getting the list. Same thing I converted into the as a as a data frame to I convert it as a list of values by using this lambda and collect function. Okay. After that, once I have this is my column list, right? In here. So what I'm doing again, I'm doing individual value I'm taking, and there I'm just doing this list of map. So for each value of my key, I'm iterating and get the data. Okay, so this is very good use case of the lambda, right? I'm going to do here. I'm getting the here key columns. I'm getting the key columns for the for list of. So I'm providing the two things. The lambda, I'm providing here the each individual like a get item, right? Value of the key I'm getting here from here. Okay, and keys list is my list of columns. Okay, total list of columns I'm providing. Okay, to my this list, right? So after that, once I get this one df, okay, so here I'm selecting for my this key columns. Okay, so what is this key columns are coming? So it is giving the data for the two column keys, right? Okay, so this is I'm getting the, then I'm doing the df select, and then I'm giving the parameter for the as okay, the whole things I'm adding in my df. Okay, so then I'm getting this data. So df, list is not callable. This is a list, I think. So this is a two separate. In this key columns, we have one map object is there, right? Okay, so in this two map objects, so this we are defining here. Okay, so this type of operations you can do. Okay, some other one is a like a flat map you can apply. So flat map is like a flattening of the data. You can apply the flat map. Here they are using, okay, they have not shown the flat map. So flat map, you can like get the all the values in a single array. So you can apply the flat map. Okay. So if I want to apply the flat map on the array column, I want to apply the flat map. So we can use the first, we can use the explode function. Explode function, we can separate it out. Okay. Or like we can, generally we have the strings values are there, and strings we have, we can use the explode to apply on explode, and then we can get the separate the values. Okay. In the array. Okay, the join is there. How many types of joins are there? Left, right outer join, left outer join, full outer join, self join, cross join. Okay, so these are the categories of the join. So if I have a two data frame, one is employee and one is the department, and I want to do these two data frame joins. So if I want to do simple inner join, so I will use the, like I have a one department data frame and one employee data frame. So there is a department ID is common in both the data frame. If I want to do the inner join, so simply in the inner join, I will use the inner keyword. I will use the inner keyword to do the join. Okay. So I'm getting the data from both the data frame. Okay. Based on the employee department ID is equal to the department ID of the department DF. Okay. So both the data frame, we are getting the data commonly, common data we are getting, that is the inner join. Outer join is when the outer is left outer, right outer. Okay. So if we use left side, all data will come. So generally this is a confusion. If we are taking a left outer join, so left outer join will be taking left outer or left. Okay. So this outer is means full outer join. Outer, full or full outer. Both are there. All three are same. So full outer or full. This is basically bringing the data from both the data frame, whether your data is matching or not matching. So if you see here, I'm getting the data from both the one, right? Even you are getting a null values here. So there is a sales department. There is no matching data in the left side. So it's all values are coming null. And one of the person, he's not associated with any department, null is coming. So if you see in the data, if you see in the data here, so sales department, the sales department is a 30 department. There is no 30. There is no 30. So that is the reason this sales department has the right side, left side null values. Okay. And the department which is here in the left side, but not in the right side, that is the 50. 50 department is there. The 50 department is, this is here, but there is no 50 department here. So right side for this row 50 will come null. Okay. So all the data is coming from left and right in the full outer. So full outer, you are getting all the data. So wherever the data is not matching, is null is coming. Here is null and here is a null, right? So if I say like 1, 2, 3, 4, and 5 and 6. 6 rows are there from the left side. Okay. And right side is the finance is 1, marketing is 1, sales is 1, and IT is 1. Okay. So 4 are there. Okay. So that is a combination of the rows from the left and right. So full outer, you are getting all the records, whether it's having matching or non-matching, all are coming. When you say left, so left side all and right side matching and non-matching is null. Okay. So if you say here, so here left side all is coming, 1 to 6 all coming, 1, 2, 3, 4, 5, 6. All the 6 employees are coming. But the right side you see 5 employees have the matching department, but 1 employee doesn't have matching department. So null is coming. So this is the left outer join. So matching data is coming, non-matching, null is coming. Okay. Right outer join is a reverse. So where the right side all and left side is matching and non-matching null. So if you see here, the four department are there. Finance is having matching is there. This finance is matching is here. Finance is matching here. Marketing is matching here. Sales, no matching. In the left side, null is coming. And IT is matching in the left side, matching is coming. Okay. So this is the right outer join. Left semi join, when the data is, okay, first we see left semi. Left semi is the left side matching data only from the right side. Okay. So you will see employee ID 13425. These are the matching. Okay. So 1, 2, 3, 4, 5, 6 is not coming. So 6 is non-matching, right? So 6 is not coming. So only matching coming. So it means left semi is something is present in the left and present in the right? Okay, but only left side data. So you cannot get the department name here. If you want to get the department name also, in that case, you should use left outer join. Left outer join you do and do the filter there. Do the filter. Like suppose you want to get department name also. Because left semi will give the left side data only. Okay. It will not give you the department name. Department ID, you can find it. Okay. This is a department ID. But department name you cannot get in the left semi. For getting a department name also, so this result and this result is same. If I say this result and the left outer join result is same, except here, if you just remove the record which are the null there. Okay. So if you filter out this record null, if you filter out this record null, so your data will be matching with department name. So how to remove this null? So simply whatever your this left join is there, you check the department underscore, or you can check department ID. The department ID is null. Okay. So I take it this left outer join. I take it this left outer join. Okay. I don't do dot filter and I say filter means is not null. I don't want is not null. I think we have to take it. Uh, is null be done, right? We have to do is not null. So when I'm doing this, is it the same result? It's the same result, right? It's the same result, except here is yeah, Venn diagram. Okay. See the diagram, Venn diagram. Okay. Simply, if you understand, see if I'm saying left is having and right is having, okay. So left ID is just think about the ID because ID is matching, then you can say other field will be coming or not coming. Okay. So this is the some ID. And if I say here is the 1, here is a 2, and here is the 5. Okay. So these are the IDs. Okay. And now I say inner join. Okay. So which IDs are matching? 1 to 1, 2 to 2. So only two are matching. So 1 and 2. So corresponding there, other field will come. Suppose this is ID and name is there. Okay. X. Okay. Y. G. And here you can say some more field is there. Okay. You are saying here is age is there. Okay. 24, 45, 50, 45. Okay. So this is age. Okay. So I'm assuming it like this is ID name and ID age. So when I say 1, I want to print ID 1, so X and 24. So this will come. 2 is Y and I say 45. Okay. Now if I say the left join, okay. So left join, I will say left side all data. So no matter what is there, first I will put it all data, and their name will come also X, okay, Y, okay, G and P. Okay. Now we start matching in the right side. So I'm matching only 24. So 24 will come and 45 will come. Okay. So these two are not matching, 3 and 4. So I will get null. I will get the null. Okay. And when I say I want to do right outer join, so right outer join, I know right side 1, 2, 5 will come, 2 and 5, and their age will come 24, okay, 45 and 45. If I see current left side, only name one X is there, one X. So X is there, okay. So X is matching, so matching is coming, okay. And here is 2 is matching, right? So 2Y is coming, okay. But 5 is not matching, null is coming, okay. So other one is not coming. But full outer join, if you do full outer join, I told whether it's matching or not matching will come. So 1x. So first we check matching one there in the full outer join. 1x 24. Second one is 2y 45. This is coming. Now when we say 3g and non-matching is there, null will come. Okay. Now we come 3 and then we see 5 1. 5, here is a null because there is no data here left side. So null 5 and 45. Okay. And the last one, left side one, 4, P and null. So this is the full outer join. So how many are coming? 4. Out of that, 2 are matching and one is 2 are matching and 2 are not matching here and 1 is not matching here. Okay. So total 5 rows are coming, 1, 2, 3 and 4 and 5. Okay. Okay. And now if I see the left semi very simple, left semi and left anti. Two are there. Left semi, left anti. Okay. Left semi is only matching, which is matching in the left to right, but only left side data. So you will get 1x, 2y, 1x, 2y. Okay. Only left side data. Okay. And left anti is from left side not matching data. So what is not matching? 3 and 4. 3 and 4 is not matching. So 3G and 4P. This is the data is coming. Okay. So sometimes I don't need to worry about my right side data. Whatever data is coming, I need only left side data. So I will go for left semi, left anti. But in this left semi, I have a matching, right? Because left anti definitely these are not having no data. So those are not my requirement. But if I say left semi, I want to get the data which is in the left. So in the left outer join, if you see the left outer join, this one, this, if you null one, if you remove it, it is the same thing. This left semi and left outer join, it is the same. Exactly, right? If I remove here this null one, if I remove this null, it will become same 1x 2y, and I will get the name also. So I have done the not null filter. So when I did not null filter, you seen that when I did not null filter, so I got it. When I did is not null, so I got it only left side data with no, with matching data of the right side. Okay. If you want left anti here, so just do null one. If you done the null one, this is the left anti result. Left anti result with right side matching, non-matching data, right? Null. So here null is coming, right? Okay. The same thing you can do with the Same thing you can do with the left anti-join. So left anti-join you can use this left anti. So this left anti-join you can use this left anti. So left anti is something is present in the left but not present in the right. So this is the left side data of this. So this is same exactly, but right side data also coming. Okay. So this is the same thing. Okay. Okay. So this is all the joins. Okay. If you want to do SQL queries, you can write the SQL queries and two tables you can create, like two tables you can create, and then you can do the inner join or left outer, right outer, all the joins you can do. Okay. So you can do with. Okay. So you can do like these two same joins with the SQL queries you are doing, Spark SQL. Okay. Okay, so do practice on this joins and everything. Just this is not very complex. Okay, you just go through once and then do one time. You just do data frame API and do the SQL. Okay. Okay. So next time I'll connect on Tuesday. Okay. So my Tuesday, Wednesday. Okay. I will upload all the recordings which are not uploaded. Today I'll do it. Okay. Thank you.
Thank you.